Extreme heat events are increasing in frequency and intensity. These heat events increase cardiovascular mortality and increase hospitalizations due to acute kidney injury, with acute kidney injury typically occurring secondary to hypohydration. Acute kidney injury is a transient reduction in kidney function, which in the short term can be fatal and in the long term increases the risk of developing chronic kidney disease. The kidneys can increase filtration when stressed because they typically operate at 75% of their maximum capacity. This increase in filtration is called renal functional reserve. A previous study found that passive heat stress reduces renal functional reserve. However, a caveat of the study is that participants lost 3% of their body water, which is a significant hypohydration. It is unclear whether these findings were due to the hypohydration caused by heat stress. Thus, an important knowledge gap exists with a high prevalence of U.S. adults being chronically insufficiently hydrated, evidenced by the 33 to 74% of the U.S. adult population not meeting one or more hydration criteria. We tested the hypothesis that renal functional reserve is reduced following prolonged mild hypohydration independent of heat stress. To test our hypothesis, we tested 20 healthy young adults using a randomized crossover design. Participants completed a euhydrated trial with normal fluid and food intake and a hypohydrated trial with 24 hours of fluid deprivation. To stimulate renal functional reserve, we used an oral protein loading technique where subjects consume a large bolus of protein in a whey protein shake. Blood and urine samples were taken before consumption of the protein shake and again 75 minutes and 150 minutes following protein ingestion. Data were analyzed using a two-way repeated measures ANOVA. Next, I will orient you to the figures. Data are represented as mean with 95% confidence intervals. The euhydrated trial will be shown in white and the hypohydrated trial will be shown in black. Figure A shows the change in body mass over the 24-hour protocol. There was a 2.5% reduction in body mass in the hypohydrated trial, which shows that our fluid deprivation protocol induced a mild hypohydration. There were no sex differences in body fluid loss. Our creatinine clearance data are presented in Figure E. Creatinine clearance was calculated using blood and urine samples to measure filtration. At 150 minutes post-protein, creatinine clearance is increased from baseline in the euhydrated trial, which is shown by the white circles. This demonstrates that the protein shake was effective at stimulating renal functional reserve. The hypohydrated trial had no change from baseline following oral protein loading. There are two potential reasons why creatinine clearance didn't increase following oral protein loading in the hypohydrated trial. The first potential reason is that a ceiling effect was reached, where creatinine clearance could not increase any further, meaning that the kidneys could not increase glomerular filtration rate any further. We predict this could be the case because maximal creatinine clearance values were not different between trials. The second potential reason is that creatinine clearance may be overestimated in the hypohydrated trial. It is possible that creatinine clearance overestimated glomerular filtration rate due to the increased tubular secretion of creatinine during hypohydration. In support of the increased tubular secretion of creatinine, urine creatinine is markedly increased in hypohydration compared to euhydration at baseline, which is shown in Figure D. In conclusion, these findings suggest that oral protein loading following prolonged mild hypohydration does not alter creatinine clearance. This indicates that renal functional reserve is attenuated following prolonged mild hypohydration, which supports the hypothesis that reductions in renal functional reserve contribute to acute kidney injury during extreme heat exposure. Thank you.